Hello everyone, and welcome to this Ansys Discovery learning track for topology optimization. In this video, we'll be covering the introduction to topology optimization. Quite simply, this will be our getting started guide. The goal of this video is to provide you with the necessary information to properly set up and solve a topology optimization simulation in Ansys Discovery. In the following videos in this learning track, we'll be covering how to specify different objectives, manufacturing constraints, as well as a variety of other tips and best practices. Let's go ahead and get started. First, let's open up a CAD model. In this situation, let's open up this oil filter assembly. It's important to note that topology optimization is only available in our Explore mode, which utilizes our GPU-powered solver. You'll also notice that this is my default mode by looking in the bottom center of my screen. You can simply navigate the modes in Discovery by clicking these arrows to access the model and refine modes if you choose. In Discovery, topology optimization is purely segmented to the structural domain. As you can see in the ribbon, my topology optimization simulation option is currently disabled. We must apply some structural conditions to enable this option. For this example, let's choose to simulate only on the bracket that we see here. Let's right-click and choose Simulate on Selection Only. From here, let's go up to our ribbon and choose a support condition from our structural dropdown and apply it to the faces that mate with the bolts that fasten this bracket to this rear support plate. Now that we have applied this condition, you can see we now have the ability to choose the topology optimization button in our ribbon. Let's go ahead and click it. Upon selecting topology optimization, we are greeted by our heads-up display. This heads-up display allows us to control a variety of different options related to topology optimization, including our objective, targets, as well as manufacturing constraints. On the left side of our heads-up display, we can access our objectives as well as scope the body for optimization. As you can see, we have a variety of options that will allow us to choose the objective for our optimization, but for this video, we'll be using the default of maximize stiffness. In the following videos, we'll be sure to take a deep dive into all of these different optimization objectives. Additionally, you can see I have a selection cursor that allows us to select the body for optimization. By default, all bodies in the simulation will be optimized, but if we select this option and choose a specific body, the solver will only optimize the selected component in the assembly. In this case, we are optimizing just a single part, so we do not need to utilize this selection. On the right side of the heads-up display, this is where we can control the target as well as the manufacturing constraints. This text box allows us to provide a numerical value for our target. In this case, it is volume reduction. Additionally, you can see we can parameterize our target so that we can run a full generative sweep of the design space. To open the manufacturing constraints, we can simply click this button to expose our controls. Each of these will help you obtain optimized geometry that is relevant for your manufacturing method of choice. Once again, we'll be diving further into this area in the upcoming videos. Let's just leave our defaults for the time being. Now let's go ahead and apply a force to our model. First, select these holes that mate with the oil filter, navigate to the ribbon, and choose force from our structural dropdown. To create a load originating from a different location, let's create our remote point option and set our coordinates to 0, 0, 0. Additionally, let's apply the force vector components of 0 in the x, 600 in the y, and negative 800 newtons in the z direction. Once we enter these values, hitting enter on our keyboard will confirm the application and add it to our physics tree. One additional consideration for topology optimization is the application of a variety of different loading conditions. To do this in Discovery, you can simply add more boundary conditions to your part or even parameterize the boundary condition values. In this case, let's optimize to a few different force values. To parameterize the force components, simply click within one of the force components and choose the parameter icon at the top of the heads-up display. Once we've done this, we can now see that our parameter icon shows 1, indicating that we have a parameter that we can modify. Let's click this icon and navigate to the Test Cases section, where we can define the various loading conditions or cases that this part will experience. As you can see, we can click this button with the green plus mark to create new load cases. It is important to fully detail each load case so that the solver can consider them all during the optimization. In our case, let's create 3 different loading scenarios. 1 for the original load that we set up, and 2 for lateral loads. As you can see, this is purely entering the values in tabular form. If I had multiple boundary conditions, such as a moment or a pressure load, I can turn those off at each load case by simply entering a 0 value. Now that we have each of these load cases defined, let's close this window and review one last remaining item. Upon enabling topology optimization, we automatically preserve regions of your part where there are physics boundary conditions or contacts applied. These default locations can be identified in the physics tree, as well as the projected distance from that surface. As you can see, I can change this value, and the size of the pink preserved areas of my part will change. If you wish to preserve another region of the part that does not have a physics boundary condition, you can navigate to the ribbon, choose the drop-down, and select Protected Depth. Next, choose a location and apply a protected depth just like our boundary condition areas. For this video, let's not preserve any additional areas. As we close out this video, I would like to show you all how to solve the topology optimization and how you can monitor the progress of the solver. To solve the optimization, simply click the Solve button in the bottom right corner. Within a few moments, we are beginning to see the solver remove material from our part. If you wish to track the progress of the solver as it reaches its target mass, please navigate to the top right corner of our window and open our monitor section. Let's go ahead and click Mass to open our monitor and further click the Details section. Here, you can see the reduction of the mass, and it will eventually flatline around the target of the optimization. As our optimization finishes, you'll notice that our Export Optimized Shape button becomes enabled in the bottom right corner of our screen in our results arc. From here, we can click this button to add an STL or faceted body to our model. As you can see, after I click this button, it is now available in our geometry tree. In the upcoming video, we will cover additional geometry operations that can be completed on this exported model. Thank you for watching this Getting Started video on topology optimization in Ansys Discovery. We hope that you found it helpful. Thank you and take care.